Show by the principle of mathematical induction that for all n belonging to the set of natural numbers n, the expression 2 times 7 raised to the power of n plus 3 times 5 raised to the power of n minus 5 is divisible by 24. Okay, let us begin. However, before beginning, we need to understand that we are not here to prove that this expression is divisible by 24. Rather, we need to show that this statement is a true statement. That means it's going to be always true for any natural number that we pick up. Okay, so let us begin. So now what we'll do, we will first consider a statement Pn. So let Pn be the statement P of n such that we have the expression 2 multiplied to 7 raised to the power of n added to 3 times 5 raised to the power of n minus 5 is divisible by 24. Okay, so this is going to be a statement. We have converted it into a mathematical statement and we're going to label this as number 1. Now, in order to show that this is indeed a true statement, first we are going to verify whether if it is true for n equals to 1 or not. That means we're going to consider the first natural number 1 and check whether if the statement P of 1 is true or not. So P of 1 means we have 2 times 7 raised to the power of 1 added to 3 times 5 raised to the power of 1 minus 5. So that gives us, so 2 times 7, that's 14, added to 3 times 5, that's 15. So we have 15 minus 5. Now when we combine them, we are going to get 24. Indeed, 24 is divisible by, it is divisible by 24. So that means this tells us that our statement, this implies that the statement P of 1 is true. That means the statement, original statement P of n is true when we choose the first natural number n equals to 1. Now in order to prove that this is also true for other natural numbers as well, we are going to suppose that let P of m is also true. So P of m is true as well. This simply tells us that we have to rewrite statement number 1 in terms of Pm. So our statement becomes 2 times 7 raised to the power of m added to 3 times 5 raised to the power of m minus 5 is divisible by, it is divisible by 24. Now here we are considering m to be belonging to the set of natural numbers. So let this be statement number 2. Okay, now that we have assumed that P of m is true, our goal will be to show, that P of m plus 1, where m plus 1 represents the natural number consecutive to that of m, the next natural number, that this statement is also true. What does P of m plus 1 all mean? So here we have to check that P of m plus 1 such that we have the statement 2 times 7 raised to the power of m plus 1. So what we have done is replacing m with m plus 1 added to 3 times 5 raised to the power of m plus 1 minus 5 is divisible by 24 as well. So we need to verify this. Okay, so let's call it statement number 3. Now in order to verify that P of m plus 1 is a true statement, we're going to take the help of statement number 2. So from statement number 2, so it's already, we have assumed that this expression is divisible by 24. So what we can do, we can consider 2 times 7 raised to the power of m added to 3 times 5 raised to the power of m minus 5 equals to, so what we'll do, we'll consider it to be a multiple of 24. So we can express it as 24 times some constant lambda, where lambda is a natural number. Fine. So we're going to call it number 4. Now we'll take the help of 4 and we'll try to verify number 3. So now let's again consider statement number 3. Now number 3, from statement number 3, we have 2 times 7 raised to the power of m plus 1 added to 3 times 5 raised to the power of m plus 1 minus 5. Okay, so what we'll do, we're going to simplify this expression. So here we can rewrite it as 2 times 7 raised to the power of m times 7. All we are doing is using the laws of exponent added to 3 times 5 raised to the power of m times 5 minus 5. So now we have 7 multiplied to 2 times 7 raised to the power of m added to, so 3 times 5 will be 15. We have 15 multiplied to 5 raised to the power of m minus 5. Okay, now in place of 2 times 7 raised to the power of m, we can take the help of number 4 and replace 2 times 7 raised to the power of m with 24 times lambda plus 5 minus 3 times 5 raised to the power of m. Fine. This is going to get added to 15 times 5 raised to the power of m minus 5. Fine. Let's distribute 7 with each of the 3 terms within the parentheses to get 7 times 24 lambda. Added to 7 times 5, that's 35, minus 7 times 3, that's 21. 21 times 5 raised to the power of m, added to 15 times 5 raised to the power of m minus 5. Now, we keep the first term as it is, 7 times 24 lambda. Then we have 35 minus 5, so that's going to be 30. And then we have negative 21 times 5 raised to the power of m added to 15 times 5 raised to the power of m. So that's going to be, we can consider it to be negative 6 times 5 raised to the power of m. Okay, now what we'll do, we will take 24 as the common factor from each of the terms. So if we take 24 as the common factor, so we have 24 times 7 lambda added to 30 over 24 minus we have 6 over 24 times 5 raised to the power of m. That is going to be equals to 24 times 7 lambda added to, so we have 5 over 4 minus 1 over 4 times 5 raised to the power of m. Now, we have already considered m to be a natural number. Lambda is also a natural number. That means this entire expression is nothing but a natural number, which means we can replace it with beta, where we have considered that 7 lambda added to 5 over 4 minus 1 over 4 times 5 raised to the power of m equals to beta, and beta is also a natural number. So that means we started out by considering the expression 2 times 7 raised to the power of m plus 1 plus 3 times 5 raised to the power of m plus 1 minus 5, and we are able to show that this is a multiple of 24. If it is a multiple of 24, this simply tells us that 2 times 7 raised to the power of m plus 1 plus 3 times 5 raised to the power of m plus 1 minus 5 is, this expression is divisible by, it is divisible by 24. So now that we have shown that it is divisible by 24, this simply means that we have successfully verified that p of m plus 1 is true. So p of m plus 1 is a true statement. Now since p of m plus n is a true statement, now we can generalize this to say that the original statement, statement number 1, p of n, such that we have 2 times 7 raised to the power of n plus 3 times 5 raised to the power of n minus 5 is divisible by 24 for all values of n belonging to the set of natural number. That means any natural number that we pick up, this expression is always going to be divisible by 24. Hence proved.